Here's a question for you. What do you think happens when we shine light on a small hole? Do you think it will create one circle of light on the other side? Well, it would, but there's more to it. And that's what we'll be explaining in today's video. Hi, my name is Celine, and I'll be explaining diffraction through circular aperture. These words might be a bit hard, so let's break them down together. Diffraction is how light acts in a specific way, which we'll explain more later on. Circular is just a small circle, and aperture is just a small hole. So if we put them all together, we will learn how light acts when it passes through a small hole. Let's first explain what light is. Light is a type of energy and it travels as waves. Now, can you think of one source of light around us? Correct. The sun is the main light source on Earth. A candle and a lamp is also an example. Light travels from these sources as waves and it travels everywhere, but it travels in a straight line. Now, how do you think a wave looks like? Just like the waves of the ocean, light waves have a high point called a peak and it has a low point called a trough. Now, using our fingers, let's draw a wave together. We will start with a peak, then a trough, then another peak, and so on. What we learned so far is that light is a wave and it travels in a straight line until it gets blocked, and that's when it starts acting in a weird way. Let's imagine this. Light is moving and it hits a flat object, say for example a wall, and part of the light is blocked. Do you think the part that isn't blocked will continue in a straight line? Well, not really. The light near the edge of the wall will curve and spread outwards. When light waves are reshaped by objects, this is called diffraction. Let's explain diffraction again, but from a different angle. Diffraction is when we shine light on a tiny hole and the light bends around its edge. But what if we place a screen in front of the light? As we mentioned before, light will not create just a single circle of light on the wall, but surprisingly, it will create a pattern that looks just like the picture. And it's made of circles which become lighter the further they get from the center. Here's another question for you. Where do you think we can find the brightest spot? That's correct. The brightest spot is in the center where rays pass through the hole. Let's look closely at the circles created on the screen. The bright circle in the middle is called the airy disk. The next bright circle happens because of the constructive interference of waves. This is a very hard word, so let's break it down. Constructive interference is when waves add together to make a bigger wave, just like the waves of the ocean. Let's test your memory a bit. Can you point at the peak of the wave? What about the trough? You are 100% correct. Now, when the peak and the trough match the peak and the trough of another wave, they join to make a bigger one. Now, when we see a shadow between two bright circles, the opposite happens. This is called destructive interference. That is when the peak and the trough of two waves don't match, and the wave will become flat and will completely disappear. And that's why we see a shadow, or there's no light at all. Scientists discovered that smaller holes will create bigger circles, and bigger holes will create smaller circles. So basically, they're opposite to each other. Now, let's do a quick experiment to see how all the information we just learned applies to our topic. Let's see what happens when we shine a torch through a circular hole. Do you see the patterns on the wall? We can see the bright spot in the middle, then the circles getting lighter. Now, can you think of an example of diffraction through a circular aperture around us? That's right, our eyes. The eye has a hole called the pupil, which changes its size to let small or large amount of light to the back of the eye. You might remember when you visited your optometrist that you put a pinhole in front of your eye, and you might remember that your vision has gotten better. This is because the pinhole will only allow the necessary light into your eye and blocks out the rest. This will make your vision a bit better. You can test it out by simply making your hand into a tube and looking through it. Now it's your turn to tell me what is one thing you learned about today. We'll see you next time.